Okay, science lesson number one in this new type of teaching world that we're living in here. You might have noticed that none of my videos are edited; they're just raw. So it's all good fun, and it should encourage you just to do your best and go ahead and make mistakes, and we'll see where we all end up. So anyway, this is the science page. So hopefully you made your way to the science page today. You can see on here that there's a video for us to watch. This is a super cool video. We're starting a new unit today called Earth Science, and it's my very favorite unit by far because that's what my degree is in, and I just love it. I'm sad that we can't be together to teach it, but there's really cool things. And the first thing we're going to start with today is the layers of Earth. And this is all theoretical, much like science in general, but certainly Earth science, because we can't go into the deep layers of the Earth. We've never been down there. As a matter of fact, this video shows how far humans have actually drilled down just into the crust, which is the first outer layer of the planet. And it's a really interesting video. So click on this video, have a watch through it, and then when you're done, come down here and you can open up the notes for today. So that's where I'm going to go right now. I'm going to open this up. So if you click on here, this should pop out, and it might give you two options for viewing. Let's see if it's going to. Oh yeah, this one does. So if you can open in Google Slides, this will open the presentation, and you literally can see it like I'm going to view it, or you can just do this. If you fall behind or you want to go back or you missed a line or something, you can just look at the notes this way. They're point form, but it's not in any kind of presentation. So for our purposes right now, as we go through this, I'm going to read through with you and just do a little chatting. I'm going to open in Google Slides here, and then I'm going to click on present. So this will show the presentation like it was intended on being. So there we go. This should be, yep, this is our presentation. So inside the Earth, what's below our feet right now? This was taken in Hawaii. I was there a bunch of years ago on the Big Island. This was not my picture, though. We weren't that close at all. But there was eruptions happening on Mauna Loa and Kilauea at the time, and there still is. It's a pretty regular thing on the Big Island. So this is a cross section. Obviously, we can't. It's a model. We can't cut a big chunk out of the world like that for a gazillion reasons. So it's just a cartoon model. But you can see deep inside the outer layer with this outer layer right here is the crust just below our atmosphere, and it's really thin. If we think of the world like a peach, that would be approximately the thickness of each layer. The fuzz on the outside of the peach would be like our atmosphere. The skin of the peach would be like the crust. And then the mantle part would be like the fruit itself. And then the inner and outer core would be like the peach pit. Okay. So just something to think about, just to visualize as we go through this. And again, it's all theoretical. We can't drill down. If you've got to this point, you probably have watched the video already, which is, if you haven't, stop this presentation, go watch the video. It's a short little one, and then come back and we'll continue here. Okay, so a side view of what this would look like. It's got some other information again, but you can see this outer crust. It's called the lithosphere. That's the top of the mantle. But all you need to know is this outer layer is the crust. Then we have the mantle. Then we have the outer core and then the inner core. And it's getting increasingly hot as we get closer to the center because of friction, because of the weight of the world is literally pressing down. The whole entire weight of all these layers are pushing down on the core. And there's some things that are really interesting about that. We'll talk about it in just a minute. I'm moving fairly quickly because I don't want to make an hour-long presentation, but you can pause at any point and write these things down. So we're going to go on a journey today. Think magic school bus kind of journey. I can't really take you there, but we're going to use our imagination. So imagine you had a machine that could dig through Earth at 100 kilometers per hour. That's like highway speed, how fast you would drive on the highway, how fast you should drive on the highway. Maybe some of your parents drive a lot faster than that, but that's the highway speed on most of our highways. Totally impossible, totally fictional. Drilling is a very, very slow process. But if there was there's been movies about it, and if there was some kind of crazy machine that could dig at 100 kilometers an hour, highway speed, straight down, this is what would happen. It would take us 30 minutes just to dig through Earth's outer solid layer called the crust. So maybe from the distance from here to Langley, but straight down. That's how big the crust is. Okay, and we've never drilled all the way through that. If you've watched that video, you've seen that I think it was 12 miles or 17 kilometers. That's the deepest a drill has ever gone down. And that's a small, like 9-inch hole. Okay. For the next 29 hours. So this is pretty significant. Well, I'm kind of blocking. I wonder if I can move this out of the way here. Yeah, I can. For the next 29 hours, you would travel through the mantle. It's a very thick layer of solid rock combined with some molten rock. Here we'd really start to feel the pressure of the upper layers pushing down. Now, why the molten rock? Well, it's got all to do with friction. If I rub my hands, I got to be really careful with my left hand because it's broken. I'll tell you a story about that one day. If I rub my hands together, it causes friction, right? And the friction causes heat. And if there's enough friction from enough pressure, that will cause melting, even rocks to melt. And their estimations of the temperature of the core are as much as 10,000 degrees Celsius, 8,000 degrees Celsius. It's very, very warm. Even at the bottom of the crust, it's hundreds of degrees Celsius already. So rock is getting really, really warm. Okay, so that's the mantle. As we go through the mantle, we enter, hopefully I can, where are we at here? There we go. Let me get to the next slide. It's not working. I'll do it this way. Here's another cross section. You can have a look at that picture. As we continue the next 22 hours, so at 100 kilometers an hour, that's 2,200 kilometers, we'd be spent traveling through the outer core. It's made of mostly liquid iron and nickel, and the pressure is super high in the outer core. So it'd be like liquid rock for sure there, molten rock. And very, very hot. The lava we see on the surface sometimes comes from deep down in these convection currents, but that's another lesson for a whole other day. Most of the lava that ends up on the surface is from the mantle. Okay, next point here. Beyond the outer core, or below the outer cores, we're moving towards the center. We have 13 hours of digging before we reach the center of the Earth. That's the last layer called the inner core. And this is really interesting because scientists believe, even though the inner core is extremely hot, scientists believe that it's solid. And you might be thinking, well, how is that possible? If it's hot enough in the outer core to be melting to liquid, how could it be solid in the inner core? The reason is the cause of the melting is actually also the cause of it not being able to turn to liquid. The pressure is so high that it should be molten rock. However, because it is so high, the material can't expand. As rock changes states from a solid to a gas, the molecules speed up and they want to expand. They want to take up more space, right? So moving from solid to liquid to gas, molecules move faster and faster. And as they move faster, they bounce off each other and they take up more and more and more space. And then the density of them decreases. So if you have a solid rock and you melt it, the molecules move faster and faster. They take up more space and they lose their structure. And that's why they become a liquid. But the pressure of all the layers pushing down on the inner core, all on the inner core on all sides, right? 360 degrees and then 360 degrees again, this sphere won't allow it to expand. It's too much weight pushing down. Literally, the weight of the world is pushing down on the inner core. So scientists believe that it's hot enough that it should expand, but it doesn't because it can't expand and take up any more space. There's too much weight pushing down. So interesting trivia question. Actually, I answered that question on Trivial Pursuit one day. It was pretty cool. There's another cross section, the same one we looked at before. And you can see that's the atmosphere, right? And then the crust is this thin little red line. And then below that, there's the mantle, then the outer core, then the inner core. And again, these are theoretical layers. There's no way of telling for sure. Another cross section here. The outside is the crust. Then we have the mantle. Don't worry about the asthenosphere. We can talk about that later. But these 4 layers, it's the crust, the mantle, the outer core, and the inner core. That's the key for today. And that's what I wanted you to get out of these notes. If you didn't get them written down, I know I'm moving very quickly. Just pause the video and write them down. Or you can get the digital copy and just write it down nice and slowly at your own pace. If you have any questions about this, we'll talk more about it. This is just an introduction today. It's really interesting stuff. Take care, guys.